Looking at this leftmost question, what reaction sequence would convert the given starting material into the product shown? The correct answer is A. If you want to know why, here is an explanation. This is a fun question that really puts our electrophilic aromatic substitution reaction knowledge to the test. Which of the sequences shown here will convert this molecule up here, good grief, that molecule up there into this molecule over here? Oh, well, I think the funnest way, and certainly the best way, is to be able to actually push through each one of these sequences and see, of course, which one will do it and which one won't. Let's go ahead and do that. Beginning right here, I've got benzene, and this is, of course, option A. I treat it with ethyl chloride, aluminum chloride. What does that do? That is Friedel-Crafts alkylation, which takes your benzene and places an ethyl group on it. And remember, an ethyl, this ET, that's just an abbreviation for ethyl, which is just that. The next step is this. This is Friedel-Crafts acylation. It places this group right here onto the ring. Where does it go? Well, that depends on what this pre-existing ethyl is. Is an ethyl a withdrawer or a donor? An ethyl is a donor, which means dope. It's going to place things in the ortho and the para position. You'll notice, of course, this product here, the two substituents are para to each other. So I'm just going to draw the para isomer, even though I understand that I'm also going to get the ortho isomer. Hopefully that makes sense, okay? Now at this point, I now take this molecule, subject it to bromine and light. What does bromine and light do? Well, bromine and light, when you have a group dangling off a benzene ring, places a Br, that is a bromine, a single bromine at the benzyl carbon, which is that carbon right there. Just in case you don't know, the benzyl carbon is the carbon that's one away from the benzene ring. I remember that by remembering a cute little song I made up. It goes, benzyl, 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 benz, one away from his friends, ooh! And you always have to do the ooh at the end or else it's, I don't know, sacrilegious or something. So I do this, subjected to these conditions, and what I end up getting is that. Now, I take this and treat it with base. It just says base, and I'm fine with that. Base is, of course, going to do an E2 elimination. That means I've got a hydrogen right there. The base comes in, grabs that hydrogen, dumps these electrons down, closes like a door on a hinge, bah! Kicks off the bromide in a single step to give me that product. Does this sequence successfully convert benzene into the product shown up here in the original question? Yes, it does. So the correct answer is A. Now, for the sake of making sure we understand everything, let's see what would happen if we did the other sequences. I take benzene here, and I treat it first with the acylation conditions. In other words, these two steps have been switched in order. What in the world is going to happen? Well, it's going to place my acyl group onto the ring. Now, I take this molecule and treat it with ethyl chloride and aluminum chloride. These are Friedel-Crafts alkylation conditions. It's going to place the ethyl group on the ring. Where does it go? Well, that all depends on the nature of the pre-existing group. That is this group right here. What is this group? It's a withdrawer. I remember W equals M. So it's going to place this ethyl appendage meta to this existing or pre-existing acyl group, giving me that product. Now, if I take this product, treat it with bromine and light, it is going to, of course, put a bromine at the benzyl carbon. What is the only available benzyl carbon to brominate? It's going to be this one right here. So that's going to take this molecule, convert it into that one. I take this molecule, treat it with base. It's of course going to come down here, grab that hydrogen, do an E2 elimination, pump those electrons down there, kick off the bromide, which will ultimately provide me with this molecule. Is that the correct answer? Well, it's not the one that we've been asked. You can see that just by switching the order of these two reactions, it ends up changing the relative positions of those substituents. Now let's go down to option C. Option C, I take this, treat it with the alkylation conditions. It of course places the ethyl group onto the ring, which gives me this product. I treat that with bromine and light. It places a bromine at the benzyl carbon, which is that position. That gives me that molecule. Now I take this and I treat it with Friedel-Crafts acylation conditions. What in the world is that going to do? Well, normally it would place an acyl group, that is this kind of group, onto the ring. Where in the world is that going to go? It depends on what the existing group is. Is it a donor or a withdrawer? And that existing group is very, very confusing because it has a bromine on it. And to be honest, I think that this bromine is probably going to react competitively with this catalyst because aluminum loves halogens.
So I think you might end up getting a mixture of crap. To be quite frank, I don't think that you get this any kind of productive reaction of work in this case. So I don't really know, but I think that you probably wouldn't get anything. Let's look at this next sequence. I take this molecule, treat it with the acylation conditions. It's going to, of course, take my benzene ring and place an acyl group onto it, giving me this molecule right here. I then take that and treat it with bromine and light. What's it going to do? Remember, bromine and light places a bromine at the benzyl carbon. Are there any existing benzyl carbons? Well, you might say, well, yeah, this carbon right here that's doubly bonded to oxygen. True, that is a benzyl carbon, but that benzyl carbon does not have any hydrogens on it. In order to put a bromine on the benzyl carbon, you have to have hydrogens appended to that carbon because one of those is going to get removed and then replaced with a bromine. So this will do nothing. So I'll write down no reaction. Okay? That indeed is going to be the case. So I'm basically going to get the exact same molecule, take the exact same molecule, treat it with these conditions. It's going to place an ethyl group, and this acyl group is a withdrawer, which means it's going to place an ethyl group meta. So I'm going to get that molecule, and then I take this molecule, treat it with base, and it's not going to do anything. There isn't any bromine there to eliminate. So that is the product I'm going to get out of that sequence. So of course the correct answer then is A.